Hail, Shmai Paub. This is Idna, and today I'm going to walk you through a HackTheBox Sherlock called HookFlare. This is a medium difficulty Sherlock from SirX58, and we're going to investigate a smishing attack followed by some deeper analysis of a malicious Android app. Let's get cracking. So here we are on HackTheBox Labs. I'm just going to come down to Sherlocks here on the left, where I can see over 100 different Sherlocks. I'm going to search for HookFlare, and here it is. And we can just read through the scenario. A Sberbank client reported unauthorized transactions. The victim received an SMS urging a banking app update via a link. This installed a dormant app mimicking the bank's official version. Once activated, it stole credentials, bypassed 2FA with SMS interception, and exfiltrated data. As a DFIR specialist, analysed the Android disk image to uncover the malware's operation, reconstruct the attack chain, and identify critical IOCs. So, first off, we need to get hold of our artifacts. So I'm going to click in here and copy the URL for the artifacts into my clipboard. And over here, I've got a Windows machine. And just going to copy that, paste that link into there, and the artifacts are being downloaded right there. Okay, so they have downloaded. Just going to open that up, extract the files here, and it asks for a password. Password is always for Sherlock's HackTheBlue. You can also get that by clicking into here. That'll put that into your clipboard. But we've got it typed in here, so we can just go ahead and extract. Okay, so that's extracted. We can look inside our artifacts, and we can see we've got a DD file, a disk image, quite large, 2 gig disk image, and a packet capture. Let's have a look at our first question and find out where we might need to get started. Provide the UTC timestamp of the phishing SMS. So I described this as a smishing attack. Smishing is a form of phishing, SMS phishing, smishing. So we will need to look into this disk image in order to get hold of that. So I've got a tool called FTK Imager open here. This is a freely available tool. You do need to register to download it, but it is freely available. So we can get this installed and open up evidence item. I'm going to select image file, and then we're going to find the source path. So that was in our downloads, HookFlare, and DD. That's pretty quick to read in, and we've basically got a folder structure of everything that's within that Android disk image. There's a disk image of a phone. It's everything that comes from within that. We could do some analysis in here, but what I actually need for this stage is just to export all of these files. So I'm going to, again, put that into HookFlare. I'm going to make a new folder called export and store them in there. While that's coming down, I'm going to find a tool called AleApp. This is here. So this is a tool that basically looks at an Android file structure and runs a report over it and extracts various bits of information from the device. So you can see sort of contents of phishing messages and call logs and this kind of thing. Sorry, not phishing messages, SMS messages, but in this case we'll be finding phishing messages. I'm going to be getting the GUI version of this, and this is a Windows machine, so I'm just going to download that here. It should come down pretty quickly, and we can open that up. Once again, extract the files, and open up the app. So when that comes in, you may not be able to see this too well, but this top folder is asking for the folder or file of the full file system. So I'm going to browse for the folder. Oh, sorry. Just the export is all I need there. Would that take the disk image? No, it will not. Okay. So I just choose the export folder. Now it generates a report. So we want to give it the output folder for that report. So I'm going to keep it in the same location here and create a new folder called report and store it in there. All of the plugins are already selected. You could untick things that you're not interested in, but we want to see everything. And we can just click process. It doesn't take very long. You can see that whizzing through. And that's just passing through all the information, extracting various bits that could be very useful. And we can click open report. And here is our HTML report. So it gives us lots of information. We've got things like Bluetooth at the top here, Chrome information, stuff that's been downloaded, top sites. So we can see it's been to Google, Instagram, LinkedIn, OS version, interesting things about the packages that are installed. We're going to be using quite a bit of this through this investigation, but we will start with just refreshing our memory on the question. Provide the UTC timestamp of the phishing SMS. There's actually two places where we could find this in here. So we've got Google Messages, and also a little bit further down, we've got SMS messages. Now we can see here that they're basically the same information. They might not be if this phone wasn't using Google Messages as its SMS application, but in this case they are. So in our SMS messages, we can see things that have been received and sent. So we've got hello, hello, hi Philip, and then we've got SirBank or S1R Bank alert. We detected a paid process of $700. This reference on your account. To confirm the transaction, please update your app now, sirbank.net/app, and call that number. Look, that does sound a little fishy, and we know in this scenario that is what we're looking for. So, and this is the timestamp that came in. So we can copy that. And that is our first answer. Question 2. Provide the UTC timestamp marking the start of the malicious application download. Right, going back into our AleApp report, we saw at the top some Chrome information. Like I said, cookies, pages, top sites, histories. But here we've got downloads. The URL s1rbank.net/app downloaded an APK file, so a package. Android package. That started to happen then, ended 1 second later, and we can see the last time that was accessed, nearly 2 meg in size. But this wants the start time of that download. Let me check, making the start of the malicious application download. So here is the timestamp for that. Now, obviously, it's a critical skill to be able to build a timeline of events when doing an incident report. So this is all information to help us get started into figuring out what happened and when. Question 3. Provide the package name of the malicious application. So once again, in our AleApp report, we can come down to packages and we can see all of the packages installed on the device. There is over 100 in total. So we could sift through those manually. We can also start to filter for keywords. So we know that this application or the APK file was S1R Bank. So we can start searching there and we find our package name. All fairly straightforward so far. Question 4. Provide the number of runtime permissions granted to the malicious application. So probably all familiar with this. Anytime you install a new app on your phone, it asks you to do various things, whether it's reading files from the device, accessing the camera, accessing the microphone if you're making calls or recording audio, things like that. These permissions are all stored around here. So we've got lots of different parts of permissions here. These are all the permissions in general. Runtime permissions is what we're asked for here. And once again, there are a lot of these, but we can filter for the app we are interested in. And we can see it's got read SMS, read call log, read external storage, and write external storage. So there are 4 in total. It's just asking us for the number. So we have got 4. And that is question 4. Provide the last access timestamp for the read SMS permission used by the malicious application. So basically saying, what time was this last access? What time was that permission last used? We can find that in the app ops XML section. So I guess application operations, something like that. Once more, we will filter for S1R, and we can see all the time these applications were used. So there's the read and the write, the external storage, the toast window, which is like a pop-up, a notification, read SMS, and read call log. So again, building our time up here, we know when it was the phishing email first came, sorry, not the phishing email, rather, the smishing text first came in. We know when the application was downloaded, and we know when it was the permissions were granted and when they were last used. So we're really being able to build this up now. You can copy that in. Question 6. Provide the URL used by the malware for data exfiltration. So for this, we will need to actually extract the APK file itself. Or rather, we've got it already extracted, but we just need to find it and analyze it. So if we look at where this might have been stored in our packages report, and it's not that, S1R, we can see that the application itself is stored in data, app, com, S1R, x58, etc., etc. So in our export, we should be able to find that. So it's inside the root, inside the Android folder, data, what was it? Data, app. And then, okay, so here is our APK file. We can't just analyze that as it is. We need to get something that is able to decompile that. And a good tool to do that for Android applications is JADX. So just find that on GitHub here. I'm going to move to releases. Actually, just have a quick look at it here. Command line and GUI tools for producing Java source code from Android DEX and APK files. So we could do some stuff on the command line here. I'm going to be using the GUI version, so I can get this from releases. And we're on Windows. I want the GUI version, and I want the version with the Java runtime environment included. So I'm just going to download that. That's already down. So as before, just going to extract that. And open that up. Okay, so open file, and we're going to find our APK file. So it's in downloads, HookFlare, export, root, Android, data, app, S1R bank, and then there is the APK. So that comes in really quickly, and for APK files, one of the first things we want to look at is the manifest file, which we can find in resources. And this manifest file kind of gives us a lot of metadata around what is actually going on here. Here we saw the same permissions that we found earlier on, the name of the application, some parts going on here, but this is where we really want to start looking at what's happening. This line here is that is basically installing a service, which is this application, and then this this part of the application is a class, I guess, or something like that. And I'm not a Java developer, I'm not a software developer at all, so I am probably continually going to mess up my classes and methods and functions and the proper terminology here. Please do call me out on that in the comments if you like that kind of thing. But nevertheless, that's what's happening here. So this APK file will install a background service, which is running the code that is inside here. Also, it will launch some additional functions of the application, I guess. This loading activity, and then inside that is main activity. So we can have a look at that. So let's open up this main activity first of all. Oh, there we go, we're in. And we can see straight away this is just creating some buttons and text. So this is probably going to be some sort of GUI being presented here. And this looks like a form that is going to be capturing some details here. So we know that this is a smishing application impersonating a bank. So it's asking for information about full name, card number, expiration date, CVV, and then there's a submit button here. So that is what's happening as soon as you launch the application. And then it's checking for some permissions. Toast is a pop-up, so it can, if it doesn't have the permissions, permission denied. If you do have the permissions, welcome to S1R Bank. Okay, so that looks like pretty much all that is going on there. So it is just popping up with a GUI asking you for some information, card details, effectively. So I'm going to maybe rename this. I'm going to rename this actually, just in case we see it referenced anywhere else. And we can call that card details. Okay, so that is the main main activity that we saw here. Let's go back to our manifest. The other thing that we know is happening is this background service. So we can also open that up and start to do some investigation and analysis around what is happening here. Straight up here, we've got a class being created, which is creating some HTTPL, or maybe it's a method. Sorry, I keep saying I'm going to be getting this the wrong way around, and I've probably done that immediately. But yeah, so this is setting up some HTTP URL connection information, and this is a key address. If we think back to our answer, our question, provide the URL used by the malware for data exfiltration. This is very likely going to be something of interest here. I'm going to carry on with the analysis for now though, and then we can come back to answering some questions shortly. So yes, we are setting up an HTTP URL connection to that URL. The method is a head. It's got a 5-second timeout, and this is looking for a 200 response code. And it's a Boolean, so basically if it gets that, it's going to come back with a true. If it's not, it's going to come back with a false. So I'm going to rename this test. Let's call it C2 up is up. So that's testing if the C2 is up. So we know that is roughly doing here. don't think that's used anywhere else, that particular variable. We could rename that in case we see it. So C2 C2, it's not really a C2, is it? I will call it that though. I just call it C2 URL check. I don't really know if we need to, I don't know if that variable will be used anywhere else. It's probably just contained within this. But this renaming of functions, when you decompile things, if you can figure out what's going on, you can give it a name that you understand what's happening, and then where that gets referred to elsewhere can help you tell the story of what's happening. So that's the first method, I guess, that is there. So next up, we're seeing the same sort of thing again to the same domain. This time around, it's sending a post. It's setting the data type to be application octet streams, just like a raw data stream. And it is sending that data out. So if this is saying if the response code is 200, it's going to return, it's going to return if it's SMS or a call log. If str is SMS or call log, it's going to come back with checking, and if not, it's going to say payment data checking. So it's basically just going to send out information and come back with something for the logs to say what's going on there. So we can also rename this. So this here, this method is going to be sending loot, let's say. And this is our, what did I call the other one? C2 URL check. Do you know what? I'm going to rename this again because I really don't like the label I've given that. So that is HTTP head S1R. Okay, and similarly for this, I don't again think we need to name this variable, but just in case, HTTP post S1R bank data. All right, so we've got these two things here. One is checking if that is up, sending a head request, giving it a timeout, and waiting for 200 error code to check everything's okay. Then we've got another one to actually send out a blob of data. Down here, we have got some other things going on. So we've got, this is just putting something into the logs. This is calling a method from somewhere else, bringing full name, card number, expiration date, CVV. So that's what we saw in that pop-up. So that's being collected somewhere and being passed to this to do something with. So let's have a look at that. So let's go to where that's declared and have a look, see what's going on here. Right, so in here, we are seeing some information get passed. So we've got the full name, card number, expiration date, CVV. So that's again the card details. This is getting those, getting the bytes of those strings, doing something with them, and then base64 encoding them. So why don't we see what this is doing? Let's have a look at what is being called there. All right, okay, so that is showing us straight away that this is doing some kind of, it's doing an AES encryption of that data using this key. So if I just go back to that previous section, the data that is inside here is again just taking the raw byte data from that and passing that to C, and C is this method here, which is basically encrypting that data with AES ciphers and this key. So we can rename C so that it makes a bit more sense. AES encrypt. Right, so if we come back here now, we can see that that rename is applied elsewhere. That same reference has been renamed. So we're starting to build up a little picture of what's happening here now. So this is an encrypted string, an encrypted bytes related to these strings here. This information is card details, and then that is in base 64 encoded and stored in this variable. So let's rename this variable. Encrypted card details. Okay. Nothing much else of interest there. Oh, actually, no, there is something else going on here. So we've got, it's going to encrypt this, and then it's going to, first of all, run that test C2 is up method. So we know that that was in here, test C2 up. That's doing their head request, waiting 5 seconds and waiting for a 200 response. If that is working, it will call sending loot, and it's going to send the encrypted card details to the details, the address is inside that sending loot. So that's the, where did I call sending loot? I'm going to rename that again because it doesn't quite make sense. I'm going to be really descriptive with this. Sending loot via post to S1R bank. I mean, that is ridiculous, but that's what we're going to call that. Okay, so that's basically saying if that is up, send that. If it is not, do this with it. We don't know what this is yet. So let's try to find that. So on this I0, this is another thing we haven't yet analyzed. What something's happened, those encrypted card details are being sent somewhere else if this is not up. So let's again go to declaration. And we can see another set of HTTP URL connections. This time go to Discord. So this is looking like it's going to do the same kind of thing. Yeah, just a post request to a Discord webhook. So this is Discord webhook. Okay, not doing much else there. That's just returning then. What else is going on down here? Nothing really of interest. So this is the bit we're really interested in here. So let's give this method a name. So that is send to Discord hook. Okay. So then once more, if we come back to here, we've got this logic again. So, sorry, I'll run through this logic again, but we've added to that now. So it's going to check if the C2 is up. If it is, it's going to send via that post request to S1R bank. And if it is not, it's going to send it to the Discord hook. So we're really starting to get a picture of what is actually happening in this application now. So you load it up. It's checking for those card details that you put in. It's encrypting them, encoding them as base 64, and sending them off to one of two listening web servers that are there. If we look a little further down here, there is some other things going on as well. So I did analyze that, but we haven't renamed it yet. So let's check this. Let's analyze this. So that is, this particular method here is the thing that is getting the card details and encrypting them. Let's just say, actually, let's just call that card details encrypted. And then if we come back to here, we can see that is now applied here. So after running these things, it is then going to, something that's going to be calling this and sending those details out. We haven't looked for this yet, and this C method. So we can, again, right click that, go to declaration, and we can see, first of all, this send loop to post to SerBank, another one to post to SerBank. This is collecting SMS data now. So that is now looking through the SMS data on that device. And I assume that's going to be sending that out too. So we can rename this SB variable that's being set here and try and make some sense of that. Right, okay, so that has built that up. And that is going through the same thing again. It's taking that SMS data, encrypting it with the AES key we saw just now, and base64ing it. So let's, and storing it in this variable here. So we're going to rename that variable to encrypted SMS data. And a little further on, we're also seeing the same thing for call logs. So yeah, so number, type, call status, duration seconds. This is call logs. Once again, I'll rename that variable to call logs. It's the same situation going on here. So this is encrypted call logs. Right, excellent. So that, now if we come back here, I didn't rename C again, is C. So this class is named here. So this is getting SMS and call data. I probably haven't been consistent with how I named that before. Yeah, I have not, but there we go. We get the point. So we have pretty much kind of loosely built up what is going on here. It's collecting some information as you open up the app that you fill in your card details. It's grabbing that information, encrypting it with AES, encoding that as base64, and sending that to one of two URLs. So this S1R bank here, and there was the Discord webhook as well as a backup. It's doing the same thing with the SMS data and the call logs. So that is fundamentally what this app is doing. If we come back to the question, provide the URL used by the malware for data exfiltration, we can answer that now. We can probably answer the next few questions based on all of that analysis. So let's grab a copy of that. We know that is the main URL that is going to be used for data exfil. and that is that. The malicious application checks if the server is live before sending data. Provide the HTTP method used for this check. We saw that here. It's the head method. So that is just simply that. If the primary server is unavailable, the malicious application redirects data exfiltration to an alternate URL. Identify and provide the alternate URL. Now that is the Discord URL that we saw, which I don't remember where it was. Here it is. And, oh, sorry, I'm scrolling the wrong way, hiding that behind my head. So let's just copy that. Paste that in. Question 9. The malicious application encrypts data before sending it to the server. Provide the encryption key used. Now, we also saw that in our analysis. So that was in here, I think. Nope. It wasn't in here either. Maybe it was in here. Oh. I know where I can find it. I called it here, didn't I? AES encrypt. So let's go to that. So this is running AES encrypt using this data here. So the secret key is this string here. There's nothing else being applied for this AES on stronger AES encryption algorithms. You would have some padding and you would probably have an IV in there as well. So this is relatively weak for AES. We'll see a bit of an example of that coming up. And then finally, question 10. Credit card information was stolen. What was the second line in the exfiltrated payment information? So we know data is being sent out. We need to be able to see that data to find out what was sent. Now, we do have a packet capture in our artifacts. And we can open that up in Wireshark, or you could use Tshark if you want to do the command line, or TCP dump, whatever it is, some kind of packet capture reader. Wireshark is obviously the primary example of that from a GUI perspective. We've got a bunch of things going on here. We don't really need to analyze the network traffic to answer this question. We can, if we really want to, we can start to see the analyze the conversations. We can see what is happening on what address. So we've only got 2 hosts here, port 80. Everything was going on, so we did see that. So it doesn't look like there was any transfer sent to the Discord backup server. We don't really need to see that here. We just want to extract the data that was sent. In Wireshark, you can do that through export objects. We know this is coming through HTTP, so we select that. And we can see 3 packets of data. I'm just going to save all of those. And let's create a new folder. We can call that loot. And save them in there. Now we know that this was AES encrypted and then base64 encoded. So we need to reverse that. So I'm going to use CyberChef for this. CyberChef is a GCHQ tool. I always try to make sure I go to the right one just in case anyone's being a bit funny. I immediately have gone to the wrong one. But this is a fantastic Swiss Army knife for all sorts of encryption, encoding, data transformations. Excellent tool. You can also run it locally if you're really concerned about sending data anywhere, but it's all client side. We can open the folder as input here. So we want to open that loot folder, and that brings in these 3 files. It's just, as we know, encrypted and encoded data at the moment. So again, to go back through that, this data was encrypted with AES and then base64 encoded. We want to reverse that. So first off, we are going to take it from base64. We're going to build this recipe up, take it from base64. And now we want to, if we search for AES here, we want AES decrypt. Input coming in is raw. This isn't a hex string here. We want to take it straight basically down the pipeline here. There's no IV. The key input is that string, so that's a UTF string. Let's copy that again from our decompiler. And there's no IV, so we know it's going to be ECB, no padding. ECB doesn't require an IV. It's one of the weaker forms of AES encryption. But as you see, that has worked. That has reversed what was going on there. We can look at the other bits of data that were extracted. Clearly, they are not what we're interested in here. This is the actual loot that was sent, and it's the card details for Philip Keeling. Going back to our question, we want the second line in the exfiltrated payment information. So that is the card number. So let's just grab that second line, enter that in here, and that is HookFlare. So that wraps up HookFlare. Thank you for watching. If you like that, please do like and subscribe. If you managed to solve any part of that Sherlock in a different or better way, please do leave a comment. I really want to hear more about that. Please check out Sherlock's on HackTheBox. There are over 100 available to play. Many of them are free, and we release a new one every Thursday. For now, diolch yn fawr.